Hello, in this video we are talking about the types of data. And so there's many ways to categorize the data. I'm sure you learned similar concept before, I'm sure you know what is quantitative, qualitative. So we kind of repeat those concepts a little bit, but also we further extending different way to classify the data. So when you work on your homework, it's very important that you are able to give you a data, you're able to identify what kind of data they are. Okay, so it's very important. The first step for making decision is to find the right data and prepare it. So compilation of facts, figures, or other content, numerical or non-numeric, all types and format are generated from the multiple sources. Often we have a large amount of data. Even small data can give insight. But it's very important you understand what kind of data you're dealing, right? Data that have been organized, analyzed, and processed in a meaningful and purposeful way become information. Okay, you cannot just call anything as information. So information has to be organized. We can use a blend of the data, contextual information, experience, and the intuition to derive knowledge. So what's the difference between data? So here, basically, I try to help you understand what's the relationship between data, information, and the knowledge. So the data is anything exists in the world, right? So like my hair color, black, it can be data. My clothes, I wear sweater, so the sweater is considered as data of my day, what I wear, right? So those are data. In order to consider data as a helpful or information in the business world, we have to kind of organize it, able to have to analyze it and the processing of some kind of insight and share, so that become information. Okay, and so when we consider knowledge, is this information is not just solid that stay there, but also move with a combine with a contextual with the experience and your intuition. That's when you're able to derive the knowledge from the information. So it's a step by step. We are going further. Okay. So it is not feasible to collect data that compromise a population of all elements of interest, but the problem is very expensive and it's very impossible, right? So therefore, if you think about in the real world, especially in the business world, when we try to understand the consumer's preference, and usually people will do is actually developing sample instead of going directly to the population because it's very expensive. There are just a few exceptions, right? The exception is the federal government are able to collect data for the population, right? So when they send out the census every 10 years to understanding the age of the population, the race, and then the marriage status, those things. So that's the census, right? Every 10 years we fill in the census. It helps the government collecting the data for our population. As you know, it's very time consuming and it's very expensive. And the reason the government can do that because they have legal requirements. So every resident in the United States, you are required to fill in the census, right? So that's a legal binding force everybody to fill in the survey. You can imagine, can any business said you've been forced to fill in a customer survey, otherwise they're gonna kick you out of the business buying their goods. I don't think any business is gonna do that. So they usually just select the samples. So therefore, it's very important you are able to identify who is sample and who is the population, right? So this is something you already learned in the prior prerequisite class. I want to emphasize again. You need to be able to understand if this is a two set of data, which set data is considered as the sample data, which set data actually is the population data. So think about this question, right? So let's see. I try to understand the United States. What is the college student satisfaction about their college? And then I went to Penn West. I surveyed 50 students, and I went to Westchester, surveyed 50 students, and I went to MIT, surveyed 50 students. And then collectively, I got let's say 10,000 data point from all universities. But then I only got 50 observation from each university. So the question here is, which data, the data I collected, is that the sample data or population data? The 10,000. Yes, the answer is sample data, right? If that's not sample data, I have to ask all the college students currently in the college, so it's impossible for me to do that. So that 10,000, that data is considered as my sample data. The question is, what going to be my population data? So the population data will involving asking every college student, every student currently in college, right? So that will become my population data. Again, you need to be able to identify what is sample data, what is population data. So you will have question in your homework assignment. So traditional statistical technique use sample information to draw a conclusion about the population. So there are a lot of statistical theory to support why you can derive insight from the sample to representing the population, and how you use the sampling technique to creating a good sample that are able to represent in population. So there's something already covered in your prerequisite class. So therefore, I'm just go through this part a little bit fast. Okay, that's one way to classify the data, sample data versus the population data. Now let me introduce in the second way to classify your data type. So I give you the example, okay? So the first example is data dealing the number of the building permits issued in November 2013 in each of the county of Ohio. The second example, data detailing the number of the building permits issued in Lucas County, Ohio, each of the last 36 months. Okay, both examples are collecting data about the building permits, right? But the difference is, thinking about these two examples, the first example, we are collecting building permit. They are all in exactly the same date, November 2013, but across different locations, right? So different counties. The second example is we are collecting the building permit always in Lucas County, but we're looking for a different time. Okay, so the way we collect these two data allow us creating two different type of data. Okay, so the first type where we fixed the time but changing the location or changing the identity, that is considered as cross-sectional data. The second example here, we are fixed the location. They are always in Lucas County or fixed the identity, right? But we're changing the time. So that data we collected is belonging to called the time series data. Okay, let me to repeat. The cross-sectional data are collected at the same or approximately the same point in time from different identity or different location. So the key here is the time is not changing. That is considered as cross-sectional data. So if I give you an example, you should be able to identify whether the data is cross-sectional or not, right? So the second type, we talk about the second example there, is considered as a time series data because we are collect over several period of time. And so the key point here is the time is continually changing for every data point. Okay, this is considered time series data. So why it's important, we need to be able to distinguish whether they are cross-sectional data or time series data, because down the road when we are analyzing the predictive analytics, so the toolkit I'm gonna give to you, which is the statistic model, some model can only be used for cross-sectional data. Some model can only be used on the time series data. So therefore, it's very important for you to understand the type of data first, and then you can pick the right model, right? So therefore, make sure you know if I give you the data, you are able to distinguish whether they are time series data or cross-sectional data. Okay, so this is the second pair of type of data, time series versus cross-sectional, right? Here, I give you more examples. So this is another example about cross-sectional data. So we look at different teams, look at their win, lose, and a winning percentage. So since they all collect at the same season, same year, and then we are looking at the different teams. So this gives us the data called the cross-sectional data. And then this is the gasoline price. As you notice that the horizontal axis is different time, and the vertical axis is the average price per gallon for the gasoline. So the gasoline price are collected at a different time point. So therefore, this is the time series data. Okay. So next way we distinguish data type is called the structured versus unstructured data. So if the data is structured, it means they reside in a predefined row column format. So basically in your homework, the case study exams, and then the final project, the data you're gonna collect, they consider as structured data. They will be in a very nice Excel sheet, and you'll be see the column name very well presented. Like that's why they said usually in the spreadsheet or database application, and then you enter, store, query, and analyze. So usually it's involving somebody entering the data, and they have some place to store the data in a spreadsheet or database. And so in order to get the data into a query using the standardized language, or you are able to pull it out directly from a spreadsheet, and you are able to analyze it immediately. So those are numerical information that is objective and not open to interpretation. So that's called the structured data. There is no information, right? They just data, no insight yet. So historically, companies rely mostly on structured data. So that's why if you run small businesses, you have the QuickBook. So the QuickBook is a way help you to managing that the structural financial data, right? Or even transaction data and the inventory data, etc., right? And then so there are high costs to store and process, as you can imagine that you have to be well organized. Somebody has to organize that data, right? And then there are some performance limitations. So this is called structural data. So oppositely, called unstructured data, so that do not conform to a predefined row column format. Usually they are textual, multimedia content, do not conform to database structure. So I'll give you an example. So when you go to the doctor office, they also ask you to fill in a patient form on the piece of paper. So you start to fill in your gender, your birthday, your email, etc., etc. Okay, and then after that, at that point, that data you generated is considered as unstructured data. Again, there is no predefined row column format. So after that, somebody in that office, they will type each value you put in that paper form into an Excel spreadsheet. So that person converting those unstructured data into structured data. Okay, so the key point here is how do you distinguish whether structured or unstructured? So for the structured data, it will be on a spreadsheet or database. If the data is not in the spreadsheet or database, so they usually is considered as unstructured data, right? So for instance, I'm talking about Erie County people living in Erie, what's the hair colors. So of course you can go on the street to look at everybody's hair. At that point, it's not structured data yet because they are just individual on their. It's a data point, but they haven't been entering in the spreadsheet. So that was unstructured data. Once you start recording everybody's hair color into a spreadsheet, that becomes structural data. Okay, so that is the third way to find a different type of data, right? So third way to classify data, structured versus unstructured. The next is a human or machine generated. So for structured human generated data like the price, income, retail sale, and then structured machine that the sensor, speed, the camera, web server logs, and then so the unstructured human data will be email, text, social media, presentation. Unstructured machine will be satellite image, video data, camera image. So the last two usually, like I said, it just exists. But for the first two, when you're using certain information management system, they'll automatically developing as a spreadsheet. Okay, so this is the third way to classify data, structured versus unstructured. And then the last one is whether it's a big data or not. So business generate and gathering more and more data at an increasing pace of big data. This is a very hot topic. A lot of people ask what is considered big data. So a massive volume of the structured and unstructured data put together. So extremely difficult to manage, process, analyze using traditional data processing tool like Excel. Present a great opportunity to gain knowledge and game-changing intelligence. So there is a rule of thumb. Like I always tell my student, like when the data is considered big data. So if the data can store in your computer, it's not big data. So the big data always require a database, and you need to learn the SQL to learn how to query data. That's when the data is considered as big data. So if your computer can store that data, your physical computer can store that data, it does not consider as big data. Okay, so this is a more practical rule, right? So although it did not mention in your textbook, but that is my practical experience. When you can consider the data you're handling is big data, it is when your physical computer cannot store that data. That will be considered as big data. So of course, when you do big data analytics, you will query a fraction of the data from your big data. You still deal with the big data, but you can store a fraction of data from your big data. So you still know how to deal with big data. But again, in order to assessing the big data, you need to learn the query, SQL, SQL. Those SQL language is very important when you are getting to the big data space. Again, in this class, we're not getting to there, okay? So it does not imply complete population data. So even it's so big, but still we don't consider that as big data, the population data. It just still gonna be a sample data. So big data may not be used when available, inconvenient and computational burdensome, and benefit may not just justify the cost. So if you run a small business, you're like, you know what, I'm gonna deal with big data. Don't do that. So when you get into the Meta level or Google level, and then those big firms, that's when they're really dealing with the big data because they have enough financial support and it makes business sense, right? Because it's very expensive. Okay. The next I want to mention is how do you characterizing the big data? So there are three characteristics of the big data: volume, immense amount of data compiled for single or multiple sources. So it's not from one data site, it's from multiple data source. So I'll give you an example. When I was in human resource department, we deal with the big data. So data coming from hiring, promotion, termination, from the employees' performance, from their interview scores. So that is large volume data. And then it's from many, many different kinds of sources, right? The second is velocity. So they generate at a rapid speed. Management is crucial issues. So think about the candidate data, right? So their interview, the big company, they hire thousands of employees every year. So those people who, that's just hiring, right? Think about how many people applied. A million people applying many jobs in a year, right? So that is the velocity. They generate at a very rapid speed. And the variety. So there are all types of data. All type form, granularity, structured or unstructured data were developed. Think about interview. You might record your interview process. The employer might record in the interview, and also you have your resume data, and you have their scoring from the interviewer, and your background check data. So there were variety. So that three characteristics for the big data. Like I said, if you're dealing with the big data, the data should not be able to store in your own physical computer. So it has to be in the cloud. So there are additional characteristics for the big data of veracity. So that's the credibility and the quality of the data has to be the reliability and the values. So the methodological plan for formulating questions, curating the right data, and unlocking hidden potential. So having having a lot of data does not guarantee that a useful insight or measurable improvement will be generated. So this is one thing I always tell my data science team that if you can use sample a small amount of data, answer the business question, well, just go ahead using that. If it doesn't work, that's when you go into the big data. The reason, as I'm explaining here, is to getting using the big data is time consuming. Take you a lot of time to clean that big data. And then of course, if you are able to derive business insight, good business insight with a small amount of data, that's not always be the go-to place. It is when you are really ran out of the idea given the small sample size, then you have to reach out to the big data. Okay. So I am thinking the big data analytics will be like second resort. It's almost, so you has to, first of all, if you have small data, try your best derive as many insights as you can. If you already try everything you can try, that's when you'll say, oh, maybe I should need to look at the big data. Okay. Yes. Fancier, difficultier doesn't mean the better, right? Okay, so in next video, I will talk about its variable and the scale of measurement.